me, I mean, if we won, that would just be amazing. You know, we're going up against 30 other schools, all from around the region, you know, that they've all worked just as hard as we have. And it's just, I mean, it'd be a great system. You know, we've put so much time and effort into it. If we actually would come out and win it, you know, that would just be amazing.
We won 2007, 2005, and 2003. Got first place in all three of those competitions. We consider it a special challenge because in the past 10 years, we haven't won an even year. We're trying to kind of break that cycle of winning the odd years and actually come through and win this year.
Well, for me as a student, I mean, it helps, you know, when we do job interviews, it's something to tell an employer that we've done this, and, you know, especially a competition like this, they may have even heard of it, and the news gets out. Some of the companies even attend the conference, so it's something big. You know, we show a project that we've worked on, and we were members of a team, and we actually got something accomplished, and they like to see that we've actually worked on something.
Well, I think the whole competition aspect of it it's important for when we go out into our careers and when we go out into our field. Some of us are going to be working for contractors for the government, for example, and one of the big parts of getting a government contract is building the better design, making the most efficient, making the most cost-efficient design possible.
Just working with the team, you know, getting that team experience, because in the real world, you're hardly ever going to be working by yourself. You know, you're always going to be you're going to be a member of a team most likely, and so just getting the team experience and learning to trust your team members when they say they're going to do something, and, you know, then, but at the same time, you know, learning to hold up your end of the bargain and knowing that they all are relying on you to complete your part of the robot. So just kind of getting that experience as working in a team, in a group together, which is what we're going to be doing in the real world.
You know, in this we're just competing essentially for fun, but when you get into the real world, you have to use these skills to really hold a job.
So it helps us as far as finding a job in the end, and then for the university, it's great recognition. You know, students coming in, we can say that we've won this competition the past few years, and, you know, it really makes our program stand out amongst the rest of the schools in the Southeast.
Every senior electrical engineer has to go through a year of senior design before you can graduate. And they will allow 2 teams to actually go do the SECON competition as their project.
SECON is called a hardware competition. It's essentially like a group of students get together and they build, usually it's a robot, some sort of project, a thing that goes and does something.
It's a student hardware competition where we compete against other universities in the Southeast for, usually you're just competing for the prestige of being one of the best electrical/computer engineering schools in our region.
You know, it's completely random. It's totally up to whoever hosted it as to exactly what the competition is. And this year it was in Huntsville, so they modeled it after, I guess, NASA and like the moon rover.
And they have, you know, different parts of it where you can go to talks about new technologies and stuff, but there's also this student element of bringing in college students to have a competition.
I've always been interested in robotics and everything, and also this meant that I didn't have to come up with a project. The project was already there for me, so we didn't have to think of a project, submit it to the professors, and, you know, get it approved. It was there, and we could just start on it immediately. So that was kind of a good motivating factor for wanting to join the team.
You know, other advantages, you basically have every professor available to you because, you know, the school wants you to do good because you're representing Mississippi State, and also the school funds it, so all the other senior design classes have to pay for their own.
The competition is divided into 2 rounds. The first round is set up where each team will play individually and compete for the highest score, and then 8 teams will move on into the final round and have a playoff. where 2 robots on the field and collect blocks at the same time.
During the competition, the robot will have to, in order to succeed and go on to the next round, that is, it has to leave its home base, for which it gets 10 points, I think, and then search the entire field for blocks. And the blocks are different colors, and those are different point values.
And like I said, it was basically modeled after like the moon rover and harvesting minerals possibly on the moon. And these, I guess, minerals were represented by colored cubes, 2-inch wooden cubes. And so our robot had to leave its home base, go out and pick up the blocks, and then return to the home base.
For the most part, the robot has to be fully autonomous. The only interaction a person may have with it is just to turn it on, and that way start the robot moving. Everything else has to be contained inside. The robot has to do everything on its own. The other major constraint is that the robot has to fit into a 10-inch by 10-inch by 11-inch box.
So that puts a pretty rigorous size constraint on us. It also has to have a bumper surrounding the 80%, I think, of the perimeter. So that also reduces the space that we have, because it has to be on the outside of everything. Work began before the beginning of last semester, actually. Some of the other team members had started working on models for the chassis and different ideas for how the robot was going to look before the semester had even started.
I began actually researching it last summer. Dr. Jones asked me to kind of read over the rules, and then we actually started construction of the playing field at the end of the summer, before the last fall semester even started.
I was here over the summer, so we actually began working on it last May, and just mainly researching components and thinking about what we were going to build.
Because senior design is generally a 4-person team, we divided our 8-person team into 2 different teams, and then we split up the robot into the 2 different parts.
We had to start out trying to figure out, our individual interests, but as well as the problem that we were dealing with and how we were going to approach that problem.
And we just kind of asked who would like to do what, and so we just divided it up that way.
We started off there, and it was really disorganized in the first semester because we started getting all the ideas together and trying to get this robot, and we didn't know really what the structure of the robot would turn out to be.
Just how are we going to pick up blocks? The basic functionalities of it, I think you have to go out and just research and figure out what is the best way to do it, and then just kind of all bring them all together at the end.
You have all these little parts, and they don't want to cooperate unless you have them working just right. So you have this mass of stuff that doesn't work at all. And the biggest problem is getting the foundation of something that works. But once you got a foundation, things started building on top of each other, and it all came together relatively quickly once you got something solid to start working off of.
Well, it's a lot like watching someone grow up in a way, because you're involved in a part of this robot for so long that you don't see it coming together, and it doesn't come together for a long time, but slowly it's building up, and then you'll see something big happen, like it moves for the first time, and then you realize, wow, we've come a long way.
But as things progressed on, each team member became an expert in a certain part of the robot. So